Hello students, we will now see how to write assembly code for Sic-Xe machine architecture. So I have taken two problems which were asked in video question paper. So let's go through this. So the first question is, write an Sic-Xe program to calculate delta equals to alpha plus beta into gamma minus 10. Okay. So, as you all know, the registers in Sic-Xe. Okay. So, you should be knowing all those. It will be easier for you to understand this as you have studied it for first internals. Yeah. Okay. Now, see here, we have how many variables? Delta is 1, alpha, beta, and gamma, right? We have 4 variables. On the right hand side, you have alpha, beta, and gamma. That is, operations are performed on these 3, and then the resultant of this is stored in delta. Okay. So, you know what LD stands for. LD is load, and A is a register, which is accumulator register. So initially we will start with alpha, okay, and then slowly we will keep adding all the other variables to alpha. So initially we are storing alpha in accumulator. Now before performing on the variables directly, we need to show how much of space is provided for all these variables. That is shown here. Alpha is being given or reserved one word, beta one word, gamma one word. Okay, even delta is there below. Okay, so this is what is the reserved word or the space that we are giving to these variables. So let us start. We have to load whatever is contained in alpha variable to accumulator, that is this register loading. Then beta is loaded onto a register by name S. Gamma is stored in a register by name T. If you remember, if you go through the machine architecture for Sic-Xe, S and T are general purpose registers without any particular function. So you can use them to load. Okay. So S has been used for beta and T has been used for gamma. Now, you all know alpha is taken initially, then beta is added to alpha, then you get a result. That result is then multiplied with gamma. Again, you get a result. That result, from that result, you subtract 10, and the result is then stored in delta. Okay. So what happens in ADDR? ADDR is an instruction with respect to registers. Okay. So here A is the initial one, right? That is alpha. So now you will add whatever is stored in S. What is stored in S? Beta value, right? That is beta value is added to alpha. S contains beta value that is added to accumulator A, which contains alpha, and the result is stored in A. As you can see, I have written the syntax of it. If you have an instruction ADDR R1 R2, then you add R1 to the contents of R2, and then the result is stored in R2. So here the result is stored in the accumulator. All the operations are performed in the accumulator. Accumulator is used to store any processing value. Okay. Now, so alpha plus beta value is now contained in this accumulator. So this accumulator should be multiplied with gamma. That means what? The gamma that is stored in T should now be multiplied to the value that is stored in accumulator. Okay. So gamma will be multiplied with alpha plus beta that is stored in A. Again, the result is stored in accumulator. Then what happens? Now accumulator has the processing of alpha plus beta into gamma, right? Okay, so what should you do? This 10 should be subtracted from the accumulator. So this is a subtraction instruction, and this is immediate addressing, which says 10 is to be subtracted from accumulator. So if you just specify 10, it shows that accumulator is used. Okay, so whatever is contained in the accumulator, from that you will subtract 10. Okay, so 10 is subtracted, and again this value will be stored in an accumulator. As I said, accumulator holds the processed value. Okay, so accumulator now holds the entire result of this right hand side. So what should you do next? Now whatever is contained in the accumulator should be loaded onto a variable called as delta. Definitely that variable name is delta, and the register that contains the value is accumulator. Okay, and the name of that location is delta. So this is what is computing any statement given using the registers with respect to SIC-XC. I hope this is clear to you. We'll now proceed to another example. Okay. Yeah. So this example is write an SIC-XC program to copy the string computer science engineering from string 1 to another string 2. Okay. So initially you need to declare two strings. One is string 1, which contains computer science and engineering, and string 2, which contains an empty string, to which you need to copy this particular computer science engineering to str2. Okay, so we will initialize that. Str1, okay, is a character constant, right? So you know byte is a constant. So here we have a constant which is a character constant which has computer science engineering, and if you count the length of this including space, guys, you get the length as 28 byte. Okay, yeah, so each word, each letter is stored as a byte, so you consider it as 28 byte string constant, and then you need another string, right, to store these values. So we will reserve bytes, that is we will reserve 28 bytes for this string to be copied to str2. Okay, yeah. Now, after you declare two strings, proceed to this particular instruction. Okay, so this is load T. Yeah, this is a T is a general purpose register, and you are loading the length of the string to this T, that is initialized register T to 28, which is the length of the string. So if they ask you any string, you should be counting the length of the string including its spaces, okay, and then initialize it to the register T. Next, since we need to increment each of the letters read, that is after reading C to str2, you need to read 0 O, right? That means you need to increment a register value. Okay, incrementing, it's just like a loop, normal loop, a for loop. So for that, here we will be using an index register which will be initialized to 0 in the beginning. Okay, so initialize index register to 0. Now here we have a label move ch which contains these 4 instructions in it. Okay, so you now know that each of the letter should be copied from str1 and then copied to str2. So LDCH is an instruction which means you load the character one by one. Okay, so initially C is read, that is in str1 the target address from where this should be read is initialized to the first byte. Okay, and X is initialized to 0, as you all know. So C will be read, okay, and it will be stored in register A, that is A will be considered like a buffer here, that is whatever you read from str1 one by one, that will be stored in an accumulator, and then from the accumulator it will be stored in str2. Okay, so initially we have X as 0. Here I'll just give you an example of COMP. Okay, so the length of this is 4, right? So here I can write this as initially the length of this string is 4 and index register is anyways 0. So initially what happens is when the string has to be read, that is initially C is read. Okay, so the address with respect to C, so I can create it like this. As I said, each letter is 1 byte, so C is located at 0 and this is at address 1. Okay, that is O, and then at address 2 you have M, and at address 3 you have P, right? This is str1. Okay, this is str1. Now this is str1. Now what happens is initially the index register is 0. That means it will be pointing to the first byte. Okay, so the first byte C is taken and then is copied to str2. Let me write it here, str2. Okay, so this is what happens. So the first one is taken and then copied to str2. Next we have an instruction tixr, which is nothing but having two operations in it. First, it will increment the value of x just like a normal loop. So this is what is written here. Add 1 to index, and then it will compare the result to the value that is stored in t. Okay. So initially what it does, txr, it will increment x value to 1 now, because initially x value was 0. Now it will be incremented to 1. Okay. Yeah, it will be incremented to 1. And then this 1 is compared with what is loaded in register T. What is loaded in register T? 4. Okay. Yeah. So 1 is compared with 4. TXR means it increments the value of index register from 0 to 1, and then it compares with the value that is stored in T, which is nothing but 4 right now, because I have taken an example COMP. Now we have a condition here, JLT, which means jump if less than. That is, if 1 is less than 4, if this is true, then you have to jump to the label move ch. That means this is a loop, right? So definitely 1 is lesser than 4, so it will go back to this move ch. Now since x is incremented to 1, you will be reading the next byte, which is 0. Okay, and then it will be loaded into accumulator A, and then from A it will be stored in str2, it is 0. Next, tixr, T means it will increment the value of 1 to 2. So next value of um, index register is 2, and then it compares with 4, which is the length of the currently taken string, right? So 2 is definitely less than 4. So if less than, then you'll have to jump to move ch. So you have jumped to move ch again. Now what happens next? You have to take the one that is in location 2. What is it? M. M is loaded onto the accumulator and then it is stored in str2. Okay. So again, when you come to TXRT, 2 is incremented to 3 and it is checked against 4, which is definitely less than. Okay. So if it is less than, you'll have to move to CH. Now at 3, you have a string P, that you have a byte, that you have a character P. So P is loaded in str2. Okay. Yeah. Now TXRT, which means 3 is incremented to 4 and then 4 is compared with 4 if it is less than or equal, less than, only less than. Yeah. So when we try to check this condition, 4 is not less than 4. So this condition fails and this looping stops here. That means now all the letters or characters in str1 is now successfully copied to str2. So this is what is the working of LDCH, STCH in copying each letter and then transferring it to the other required string. The explanation for this is given down. You can go through it. So consider these two as important examples. So if you have any questions with respect to arithmetic operations, that is as I have shown you in example 1, you have to perform this way. If it is with respect to copying a string, this is how it needs to be done. Thank you.